The universe is clearly vast, so are the conditions we experience here on Earth common, or did something very special happen during Earth's formation that enabled our planet to evolve and progress to the point that we can develop life? My name is Hugh O'Neill and I'm an Earth scientist.
Well, these are rocks you've worked on all your life in one way or another.
Absolutely.
I make rocks to simulate what happens in the depth of the Earth. So this is done in order to understand the big picture about how the Earth formed, how it's evolved over geological history, which is 4,500 million years or so, and how it's working. We experiment both on natural samples, but we also construct our own rocks out of jars of chemicals to look at how the mineral compositions within the rocks changed with temperature and pressure, and then apply this looking at natural rocks that we obtain from, say, volcanoes. So, for example, we know that diamonds come from very deep in the earth, but it is of some considerable interest to find out exactly where in the depths of the earth they come from. And by looking at the rocks that are brought to the surface along with diamonds and their particular mineral chemistries, we can tell you. And that is how, in fact, some of the big diamond mines around the world have been discovered. The composition of the Earth has been a long-standing interest of mine. Substantial amounts of knowledge come from the study of meteorites and their chemical compositions.
So this is an absolutely classic meteorite.
Seeing how their compositions vary from one kind to another is really informative.
You can actually see when you do the thin sections.
Thinking about the processes that occurred in the very earliest million years or so of the solar system's existence, prior to the formation of the Earth and the other planets. What I really appreciate doing is taking my own speciality and meshing it with what I learn from other scientists to build a larger picture. I strongly believe that science is a collegial enterprise in which collaboration is essential, especially in the earth sciences, because different countries have different rocks and different approaches to researching those rocks, which all increases the sum of knowledge. I've been aware of John Jaeger ever since I arrived in Australia. He was the formative figure in starting an earth science activity at the ANU. He wasn't an earth scientist by training. He was a mathematical physicist, but he brought in a really inspirational range of scientists who populated the generation before myself. And I've personally absorbed a lot of my attitudes to science from these great names. So to be associated with the person that I regard as being the father of it all, it gives me enormous pleasure.